Welcome back to another episode of Security Simplified. Tonight, Evan and I will be picking up where we left off last week with Nmap and Nmap. Tonight, we're going to talk about what to do with the results that we've generated. So hopefully, last week you ran the scan either against the test environment that we showed you or preferably within your own home. So tonight, we're going to review those outputs, talk about what to do with them, and maybe look at a couple of the options if we have enough time. So with that, I'm going to turn it over to our good friend, mentor, and shepherd, Evan, who is going to take us through the results.
Thanks, man. It's good to be here. I'm not in Mexico, so there's no, sirens or anything, so it's good. So what I have showing right now on the screen is the results of just the safe place to scan, really, scanme.nmap.org. You could have done the same thing with, in your home. If you know how to find what your IP address is and what your network address is. The suggestion from last podcast was to scan your entire home network, realizing that I can't possibly protect the things I don't know I have. So that was the segue into using Nmap as an asset management tool, or at least an asset inventory sort of collection tool. So what I have showing on the screen is, what ran on this particular scan. So at the beginning, you see the version of Nmap, and you see the date of the scan, the date and time of the scan, and then you see a whole bunch of things, right? Initiating NSE. NSE is a network scan engine, the time that went and how long it took for it to execute. And then a little bit lower down, you'll see scanning, scanme.nmap.org, and you see an IP address. So it did our IP address resolution there. And for IP address resolution, for people who don't know how that works, it uses what's called DNS, so the domain name system or service, depending on where you come from. And what those do is basically resolve that name, scanme.nmap.org, to an IP address. Now we did the intense scan, so you see the ping scan starting at 2025. That's 8:25. That's the 24-hour clock. You can disable the ping scan by doing a -p in the command. So you can see, again, when we did this scan, we chose the intent scan. You can see the command below that in this Nmap window. If I took that command and ran that from a command line, I'd get the same results. So when I talk about adding a -p, that's what I'm talking about, is in that command. But here we didn't. We just did the plain old default intent scan. So we completed the ping scan, then we see, parallel DNS resolution, just ensuring we have that correct. And then a little lower down, you'll see 1,000 ports. So that's the default with an intent scan, is Nmap will scan the 1,000 most common ports. In TCP/IP, there are 65,535 ports available. And like I said in the last podcast, a port really is a network-enabled service or a network-enabled application that's essentially listening for traffic so that it can process it and do its work. Different types of applications might be using different ports. Now, we block ports when we talk about a firewall. Sometimes we put a firewall between us and somebody else, or us and maybe the internet, and we might block those ports. But here, these ports are open, meaning from our scan system here at my home, when I ran this Nmap scan, these ports were available. So in the way it works really is Nmap will send what's called a Syn Packet. When you do a TCP connection, the first packet that goes out, it's called a Syn Packet. What you receive back is called a SYN-ACK packet. And then you'll complete that three-way handshake with whatever you're communicating with, if you're using TCP/IP, with an ACK back. So it's called SYN, SYN-ACK, and ACK back. So what happened was my system sent a Syn packet, and that's really just a request to synchronize. It's the first packet in this connection. And what it received back was a SYN-ACK. And that's what triggered Nmap saying, yeah, this port is open. So we have 4 ports in this particular scan of scanme.nmap.org that reported as open, right? No firewall in between them that was blocking traffic. We have some service, some application listening on these ports. So the first port is 22. The second port is 80. We've got then 31.337 and 99.29. So don't get intimidated by a bunch of numbers and things you don't understand. The first time you see this stuff, it seems like a different language, and it is. It's a different language. It's a protocol. It's the language that the computers are speaking when they're talking on the internet. As you start doing this more often, you'll start to speak the language a little bit. So these 4 ports were all TCP ports. So that's why you see the 22/TCP and then on and then the IP address. So 22, I know what that port is because it's a default port. That's SSH. Sometimes SFTP, same protocol, just used in different ways. Port 80, that's your web. It's a web server that's listening. Now, in a default sort of configuration, that would be an HTTP, just plain HTTP, which means plain text. So there's no encryption. Sometimes we talk about HTTPS. That's port 443 by default. So that one's not listed here. This is just a plain text HTTP daemon is another way to say service that's listening. So we have these 4 ports that are open. Now, one of the things I caution newer folks when they're using these tools is this is just kind of the first indication, right? If I really wanted to confirm that TCP port 22 was open here, maybe I would fire up a utility on my own computer and try to connect to that port and see what I get back as a response. Because when you connect to a lot of these daemons, you'll get a response back just to confirm that it is actually 22 actually is SSH, and confirm that 80 actually is HTTP. And you can do that just by opening a browser and typing in the IP address. So that's and I'm going to leave it right there really quick because I want to give Ryan a chance to talk as well. But that's what we've learned so far about this one particular host. Now, when you scan your home network, you're going to see a whole bunch of hosts potentially that will show up. Like I said in the last podcast, the average home in the United States has 11 systems connected to the home network. So you'll see the same thing, but just with a whole bunch of hosts. Ryan, you got anything to add?
If you are doing this at home, if you have a Windows machine, you can open up a command prompt and type in IP CONFIG or IP config. And what that'll do is tell you what the IP address of that device is. So as you go through these results here in Nmap, it doesn't have a name associated with it, right? So I don't know if that's my iPad, is that my Xbox, is that my laptop, what is it? So one of the ways that I can find out on a Windows machine is to do the IP config. In Xbox, in the settings menu, you can see what IP address is assigned. I'm not an Apple guy, but I know somewhere in the settings in Apple, you can pull up, what the IP address is.
Yeah, so just like on Windows, Apple has a Linux kernel, so it's if config on an Apple.
So that'll be the way that you confirm whether that IP, what device that IP address is. And then from there, we can look deeper into, the ports. For example, I probably shouldn't have a web server running on my laptop unless I've intentionally set that up. So if I find these things open in broadcasting, that might be something that I want to further investigate. But an important part of this information and why you want to do that validation step of confirming what address is associated with what device is that becomes one of the first steps towards inventorying which devices you have, what they do, and what they should be doing, which then leads you to discovering if they're doing something they shouldn't be doing.
Mm-hmm. Yeah, good point, man. And this stuff is, your first time it's not going to seem basic, but this really is basic. This is, kind of where you would start. And this is oftentimes, where I would start if I was a hacker, right, or an attacker. Actually, I do a little bit. I do something even before this. I do something that's called OSINT, which is try to figure out things about my target without ever sending any traffic. Because one of the things about doing a scan is the target is also seeing this traffic. So if there is somebody monitoring what's going on, this might trigger something. So, oftentimes oftentimes they'll scan, but, some of the more sophisticated ones won't. But when I scan my own home network, and don't just do it once either, you can, if you get more sophisticated later on, you can, script these Nmap scans to run. You can create a little Raspberry Pi, plug it into your network. You can do all kinds of really cool things with this. So this should, if you've never done this before, hopefully this is a fun learning experience. It's supposed to be fun. You can also see on the screen, I've got a couple other hosts listed on the left side. That was just another scan that I ran. So in Nmap, it'll just continue to accumulate these scans. And the one that's sort of interesting is the www.webgui, so webgui.nokiawifi.com. That's actually my Wi-Fi router right behind me. So it was just another scan that we could use, as an example. So all kinds of things. I mean, it truly is. Nmap is one of my favorite tools to use because it's so flexible. I can do so many different things with it. I mentioned the 1,000 ports. I can scan all 65,535 ports if I want to, or I can specify just a few. So pretty cool stuff. As we continue to go into the results of just this normal Nmap scan, you see there's another script that starts kind of halfway down. And that script is going to execute fingerprinting. It's going to try to determine the operating system of the host that's responding. So you can see further down in the results and again, you will get the same exact results from me if there's no big filtering between you and scanme.nmap.org. You'll see the same results I'm seeing. So if you wanted to follow along, yourself, that's one way you can do it. So a little further down, you see some fingerprinting, information. So Nmap, part of this intent scan connected to the port for me. So it's confirming, and when I look at the SSH-host key, and I see a whole bunch of what looks like mumbo jumbo there, that's actually the key. So like I mentioned, SSH, SFTP, that's encrypted. So there has to be some method to encrypt and decrypt the traffic, and what it'll use is these keys, right? So that's what that is, and I'm not going to go into detail on that. You can see that Nmap also identified a version. So here it's OpenSSH 6.6.1P1. That's interesting when I'm doing inventory because, like I said, first you have to inventory hardware, then you got to inventory software. So now I know that this version of software, there's probably other stuff as well, but this is what's exposed on the internet or on the network. I can then see if OpenSSH 6.6.1 P1 is a current version, if it's an old version, if this thing might need a patch. Again, this is my first scan of this network, so I'm going to confirm all these things before I rush to judgment. This is kind of the first indicator. A little further down, you see that we enumerated, or Nmap enumerated some stuff with port 80. There we've got Apache HTTPD. The D stands for daemon, so Hypertext Transfer Protocol daemon. 2.4.7 running on Ubuntu. Again, it's good information, but if I was really going after this, I would confirm that before I started doing anything else with it. Then we see some methods. That's all part of the HTTP header. So that's just a language, again, another language. HTTP is its own protocol. Protocol sounds like a really fancy word, but protocol just means rules. Right? This is rules for the language there. And then two more ports, 9929 and 31337. 9929 is nping. It's an echo. Nping is just a network utility tool, not widely used, and probably doesn't need to be running. And then we've got 31337 is what's called an ephemeral port. Actually, both of those are ephemeral ports. throwing a whole bunch of words at you, but ephemeral means all the ports above 1024, so 1024, those are called ephemeral ports. Ports below that are assigned by what's called the Internet Assigned Numbering Authority, and they're typically reserved for some application. So when you see those kinds of numbers, so ephemeral ports, typically your system has a port when it goes to reach out and connect to another system on a port. When you have the IP address combined with port on both sides, that's called a socket. And I'm throwing this out there not to confuse you, but maybe you go look up these things, as you progress in your own understanding of how Nmap works. But when my computer wants to connect to another computer, it's going to use a random ephemeral port. It's going to use a port above 1024 to initiate that connection. That's sort of important when you really dig deeper into packet inspection. You start capturing packets, things like that. You don't do that with Nmap, but I mention it, sort of for that reason.
Well, and I think it's good you bring it up because, next week's episode is going to be on the TCP IP basics. So a lot of the terms that you've heard tonight, ports, what is that? We're going to go a little deeper into that detail. We're going to go a little deeper into what is a packet, what is a header, how does that handshake really work at a hardware level, at a software level. So we're gonna unpack that for you next week. Any closing thoughts on Nmap, Evan, as we roll out the show here tonight?
My closing thoughts are: don't be intimidated. Run it. The biggest thing I think for me and you and other people who have hacked or are hackers is this curiosity. So when you see these things, if you don't know what they mean, Google it, look it up, ask somebody, because computers only do what we tell them to do. So don't just chalk it up as some random occurrence. I would just encourage everybody to not be intimidated and, dig in.
Well, I appreciate everyone tuning in tonight and listening to this. If you have any questions about Nmap, if you'd like to see us go deeper in any particular area, please do leave a comment for us on the YouTube. And we'll continue to do this. We'll be planning some new episodes. So again, if you have a particular topic you'd like to see us dive into or do a deeper dive, over a couple of episodes, just leave us a message in the comment section and we'll be sure to get to that. Appreciate everybody. Hope you guys have a wonderful week and we'll see you again next week.
Awesome. Take care.